Assalamualaikum. My name is Nabiha binti Zulbatuwahan. My metric number is AA201028. Today, I will explain about question 1. First of all, we need to find the equation loops by loops. From that, we will get 3 equations from 3 loops. After that, we need to solve all of the 3 equations by using a calculator in EQN mode. From that, we will get 3 values: x, y, and z. For x, you will get 3.671. For y is 1.442, and lastly z, you will get 1.791. We will use all of these values to answer the question. X value is a I total. Y value is a I1 value. Z value will help us to find I2 value. To find I2, we need minus Z value from X value. Then, for the V value, we can use the formula, which is V equal IR. Next, for the power supply, we need use P equal VI formula. Lastly, we will run the answer at multisim like this. You will get the value of I2 is 1.88 ampere. Meanwhile, for the value of I1 is 1.44 ampere. For the power supplier, you will get negative 1.84 kilowatt. And for the V value, we will get negative 20.958 volts. That's all for me. Thank you.
Assalamualaikum. And today I would like to explain to you for the second question. First of all, we need to label V1, V2 and V3 at the circuits like this. After that, we need to label the part of incoming currents with an arrow. Once done, we proceed with the formula. We will use the Kirchhoff currents law formula. This formula indicate that current in equals to current out. We will use this formula in V1. In V1, the current is only the 5 ampere, and the current out there are 4 here. This one, this one, this one, and this one. So for the currents out, we need to add all the currents out. Because there are no current there, we will use the Ohm's law where V equals to IR. So after the calculation, we will get this equation, and we will name this the first equation. Next, with the same step, we will use at the V2. So we will name the currents in and the current out. After the calculation like this, we will get the second equation. With the same formula, we will use at the V3. There are 1, 2 and 3 current ins and only 1 currents out. So refer this calculation, we will get the last equation. So For the last step, collect all three this equation using equation mode in the calculator. Enter all the information based on the three equation. So we will get the final result that we get is V1 equals to 10, V2 equals to 4.9, and V3 equals to 12.3. To be sure, we will try to check the result by using the multisim. So after enter all such circuits in the question, we will run this to find out the final result at the same with our calculation. So after on, we will get the same equation like our calculation. So that's all it.
Assalamualaikum. My name is Shamila binti Salim. Right now, in third question, I will explain how to use mesh analysis to find the branch current IA, IB, IC, ID, and IE. In this figure 3, have a dependent current source between loop. So I apply supermesh, and when use supermesh, need to find the supporting equation. In this circuit, I labeling loop I1, loop I2, and loop I3. Then loop I1, I find the first equation. When to find the first equation, need to apply KVL, is mean Kirchhoff voltage loop. And next, at the supermesh loop, I just use this component to find the second equation. Third equation is supporting equation, and this is supporting equation. To find the 4.3 ID equal I3 minus I2, and ID equal I1 minus I2 in this circuit. Finally, to solve equation 1, 2, and 3, to find the I1, I2, I3. This is answer for I1, I2, I3. Last, IA equal I2 because IA at loop I2. IB equal I1 because IB at loop I1. IC equal I3 because IC at loop I3. Then ID equal I1 minus I2 because ID between loop I1 and loop I2. IE equal I1 minus I3 because I3 because IE between loop I1 and loop I3. This is answer of current using mesh analysis. To prove the answer is correct, I using multi. This is circuit in figure 3. I using probe current voltage, and this current control current source. So I just run. Alright, this is answer. This is answer of current. That's all. Thank you.